Hello students, this is Taran, class 10th mathematics teacher. In continuation with chapter 2 polynomials, today we are going to start the new topic, that is relationship between zeros and coefficients of a quadratic polynomial. Before we begin with today's topic, let us first recall the concept which you had already studied in class 9th, that is linear polynomial. If you are given some linear polynomial and you are asked to find the zero, there is a very simple method. Just put the polynomial equal to 0 and you will get the answer. I hope you remember it. First of all, we put 2x plus 5 equals to 0. Solving it, we get x is equals to minus 5 by 2. This is the 0 of given polynomial. That means this is one such value which on substitution in the polynomial, if we put minus 5 by 2 in this polynomial, on solving it will definitely give 0. So that is why it is called 0 of the polynomial. Now in our syllabus we have a quadratic polynomial. So if I write a general quadratic polynomial, it is written as ax square plus bx plus c. Herein we are having single variable x with degree 2. So this is called quadratic polynomial. A, B, C are the coefficients of different terms. If we find the zeros of this polynomial, just because the degree is 2, we are going to have two zeros, that are alpha and beta, say. We suppose that the names given to the zeros of this polynomial are alpha and beta. Then there is a relationship between these zeros and these coefficients a, b, c, alpha and beta. There is a relationship between them. What is that relationship? Alpha plus beta, that is sum of zeros, is always equals to minus b over a, and the product of zeros, alpha into beta, is always equal to c upon a. In order to understand this relationship between zeros and coefficients in a better manner, we'll just take an example. Now see here, I have a question with me. Find the zeros of the polynomial x square plus 7x plus 10 and then verify the relationship between these zeros and coefficients. First of all, it should be clear to you that you need to find the zeros of this quadratic polynomial which is given to you. In order to find the zeros, we'll use the old method which is with us, that is the factorization, or you call it splitting the middle term. Now herein I want to split this 7x. The middle term is 7x, so I need to split it. For this, I want to find two numbers whose sum is 7 and whose product is 10. So by using hit and trial, I can say 2 plus 5 will give me 7 and 2 into 5 will give me 10. So I can write this polynomial as x square plus 2x plus 5x plus 10. Just see here, I have split this middle term into two parts. Now we'll do the pairing and then we'll take terms common. After taking common, we get two factors of this polynomial, which are x plus 2 and x plus 5. Now this is the method which you've already studied in class 9, factorization. Now for finding the zeros of the polynomial, what additional step we have to do? Put first factor equal to 0 and find the value of x. Same way, put second factor equals to 0 and find the value of x. Now these values of x are the zeros of this quadratic polynomial. Again I am telling you, just because degree is 2, you will get two zeros. We say the first 0 is alpha and the second 0 is beta. We have given the names alpha and beta to these zeros. Now we are going to do the verification of this relationship. As I told you earlier, that in order to verify the relationship between zeros and coefficients, we know that sum of zeros, which is alpha plus beta, equals to minus b over a, and the product of zeros should be equal to c over a. We need to show these two things. How we'll show these two things? First of all, you find alpha plus beta. Both the values are there with you. Just use these values. You get minus 7. Now find minus b over a. Where will this a, b come from? Now get back to the polynomial which was given to you. Now on comparing this polynomial with the general polynomial, that is ax square plus bx plus c, you need to compare this polynomial with this general polynomial. x square coefficient, herein it has a, and here the coefficient of x square is 1. So that means a equals to 1. Coefficient of x is b, here the coefficient of x is 7, so b is equals to 7. Constant term is c, which is equals to 10. So this way we will find the value of a, b, c by comparing the given polynomial with the general polynomial. Now I will use these values over here. B is 7 and a is 1. So on solving we get minus 7. Just see here, alpha plus beta is minus 7, then minus b upon a is also equal to minus 7. Therefore, alpha plus beta is equals to minus b over a. We had to show this, we have shown. Now second relationship says the product should be equal to c over a. First find the product of zeros, that is minus 2 into minus 5, you get 10. Now find c over a. Again see the coefficients here, 10 upon 1, that is 10. So these two are also equal. We'll write therefore alpha into beta is equals to c over a. So this way we have verified the relationship that sum of zeros is equal to minus b over a and product of zeros is equal to c over a. You will write hence verified. Now we will discuss one more question based on the same topic. See, I have a polynomial x square minus 3 with me. First of all, I need to find the zeros and then the same verification process is to be done. For finding the zeros of this polynomial, see, first of all, let us compare it. On comparing with ax square plus bx plus c. On comparing, you get a is equals to 1. The coefficient of x square here is a and here it is 1. B, the coefficient of x is b, but herein we are not having any term which is b having x. So b will be equal to 0. The constant term is minus 3. So we have got the coefficients with us. Now if the term containing x is missing, you can simply find the zeros. Just see here, write x square minus 3 can be written as the square of root 3. This becomes a square minus b square. Use the identity a square minus b square is equals to a plus b and a minus b. Now we have got two factors with us. How we will find zeros? X plus root 3 equals to 0. First put this factor equals to 0. You will get x is equals to minus root 3. Then put the second factor equals to 0. You will get x is equals to root 3. Now here alpha is minus root 3 and beta is root 3. Now these are the two zeros of the polynomial. Verification you will do in the same way as we had done in the first example. Now another type of question that can be asked in the paper. The question is same, you need to find the zeros and then you have to verify the relationship. But the difference here is if you compare this polynomial with the general polynomial, that is ax square plus bx plus c, here you get a is equals to 4, b is equals to 8. Now see here, in this question the variable is u. Generally we write the variable x, but the variable u, y, z, t can be used. So here in the question has variable u. If I compare the values, I just need to see that the coefficient of quadratic term should be a, coefficient of linear term should be b, and the constant term should be c. But here we don't have a constant term, so we will write it equal to 0. How we will factorize this polynomial is, if you have a polynomial wherein there is no constant term, you simply take things common out of the given polynomial. I can take 4u common and I will get u plus 2. Now this is first factor and this is the second factor. Put first factor equal to 0. You will get 0 upon 4, that is 0. Put second factor equal to 0. You will get minus 2. That means alpha is 0 and beta is minus 2. Now you got the zeros. Again, you can do the verification process as we had done in first example. Now, another type of question that can be asked, which is related to this topic. Find a quadratic polynomial, the sum and product of whose zeros are -3 and 2 respectively. Now you are given sum of zeros is -3. We write it as capital S. It is equals to -3. And product of zeros, it is 2. We write it capital P is equals to 2. Now, if sum and product are given and you need to write the polynomial, what you will do? The required polynomial can be written as k in brackets x square minus sx plus p. Now, this thing you have to learn. The quadratic polynomial is written as k. Why we have used k over here? Because there are infinite polynomials which can have sum -3 and product 2. So we write here k to denote that the polynomials are infinite. And in brackets we write x square minus sx. S is the sum of zeros and p is the product of zeros. Now just simply put the value of s and p over here. You get k in bracket x square plus 3x plus 2. Now this means infinite polynomials are obtained. But you need a polynomial. Just see the question says a quadratic polynomial. So what we will do here is we will put k equals to 1. In order to get one polynomial, we will use one unique value of k over here. So the quadratic polynomial becomes 1 into x square plus 3x plus 2, that is x square plus 3x plus 2 only. So this is your required answer. In this way you will try the questions of exercise 2.2 of your NCERT book. There are 2 questions only. The first question is finding the zeros and verifying the relationship, and the second question is finding the quadratic polynomial if sum and product is given. Now in question number 2, your answers may vary. The answer which is given at the back of the book may not be the same as your answer, because I told you we can have infinite such polynomials. So need not worry if your answer does not match. But the process of doing the question should be the same. Thank you.